Don't lose the note card. It'll be a good practice, but you have to keep up with something. All right. So a sphere is a round, solid figure, or its surface with every point on its surface equidistant from its center. What do you guys think that word equidistant means? Equal distances, basically. Like, so if you think, like, you may have seen before, like, if you need to draw a circle, you can take, like, a piece of string and tie a pencil to it and just go around in the circle. You can make a perfect circle, right? So, another example, that's a 2D example, right? If you can imagine, if you had, like, a fixed point and you had a string, and you could just like swing it around in every direction and it would create a surface, then that would give you a sphere. So it's like a circle, all the same distance from the center, except for it's in every direction, right, to make it 3D. So volume of a sphere we need to add to our note card. So we're not going to try to draw it. If you're good at shading, you can try to draw a sphere. I'm just going to write the word sphere. I'm not. I don't think I can do it. I'm going to add. I'm just going to find like a little corner to add sphere here. And we got volume equals pi times, 4/3. Pi times the radius cubed.
During a test, can I phone a friend?
Nope. Okay. So, notice the biggest thing, like sphere should be like the easiest one we do because it's only got one variable. But kids miss it all the time, and the reason they miss it is because they do a square instead of a cube, right? So it is 4/3 pi r cubed. Make sure you have that correct. The other formulas have a lot of pi r squares in it, so people do this one wrong pretty often. But as long as you have the formula written down correctly and use it correctly, it's usually one of the easier ones that we do because there's only one variable to plug into it. So, for example 6, the radius of the moon is approximately 1,738 kilometers, and the radius of the Earth is approximately 6,378 miles. Oh, I don't think I meant for that to be the case. I don't think I meant to do kilometers and miles. Let me look this up real quick. I think that's a typo. Radius of moon. Alright, I want kilometers and kilometers. Alright, 1,737, is that? Yeah, that's what I got. Okay. And then radius of Earth in kilometers, 6,370. Okay. That is just supposed to be miles. That is supposed to be kilometers right there. My like American brain took over and changed it to miles because I was not thinking of. So let me fix that. Mark that out and change that to kilometers. I didn't mean for those to be different units because that makes it a much more difficult problem. Let's go back. Okay, so fill in the blank. The volume of the Earth is blank times larger than the volume of the moon. Okay, so for this, we're going to need to find the volume of the Earth and the volume of the moon, right? So if we're going to do volume of the moon, I'm going to call it V with the moon, like that's my subscript. That would be 4/3 pi times the radius, 1738 cubed. And it's probably going to be a huge number. Let's open Desmos so I can type that in. Okay, so we've got 4/3 pi times 1738 square. Oh, no, see, look, I just did it. I just warned you, and I just did it. It is cubed, not squared. Oh, good gracious.
What is that?
All right, this is scientific notation because the number is too big. So, we got, but let's just write it down. We got 2.19. Oh, good gracious. I need to show. 2.199. We just do 2.199 times 10 to the 10th power. That'll be close enough for getting us a good answer here.
So when we get it wrong, we'll take that off.
Our final answer, it'd be better if we like kept the whole thing. Our final answer though for this is our final answer is going to be like a number we don't have to use scientific notation for. I'll show you in a second. And like something like this, I probably wouldn't give it to you on the quiz or test because of such big numbers, and it makes it hard to get the right answer in the end. But doesn't mean it's not good to look at here. All right, so for Earth, we would do the same thing. 4/3 pi times 6,378 to the third. We're going to get an even bigger number here when we type this into Desmos, because when we change this number to 6,378, we get 1.087. So that looks like a smaller number, but why is it bigger?
Yes, I want that.
10 to the 12th. So if you remember from scientific notation, what we would have to do is we would have to move that decimal 10 places for that top one. On the bottom, we'd have to move that decimal 12 places for that. And this would be kilometers cubed. Kilometers cubed. So how am I going to answer this? How am I going to tell how many times bigger the Earth is?
Just figure like 2 times. What? Since the Earth is like 12 and the moon is 10, it's bigger by 2.
It's 2 decimal points multiplied by 10. So let's do something. Let's pretend the Earth was 10 and the moon was 2. How many times bigger is the Earth than the moon?
8,
Nope.
9.
How many times?
Oh, 5.
It would be 5 times, right? So what I could do is Earth, which is 10, divided by moon, which is 2, and that'll give me the number of times bigger that it is, right? So obviously it's not 10 and 2. So we got to do the Earth divided by the moon. And I should have, so over here in Desmos, I guess I could do this. Let's do this. That's Earth. Let's change that back to moon. 1738. Okay. So I'm going to take this number right here. Oh, it didn't do it. Let's do 2 to the 12th. It might not like that X right there. I don't know. We'll have to see. I can't tell. Okay. All right. So I've got the volume of the Earth divided by the volume of the moon, and it is giving me 49 point, let's just go 42, 49.42 there, so 49.42 times larger. Okay, now here's something I want you to recognize. Okay, how many times larger was the radius? About 6, right? Maybe a little less than 6. Like if I take the radius of the Earth, 6, 3, 7, 8, and divide it by the radius of the moon, 1738, it's actually only like 3.6. It's like less than 4 times, right? So the radii, you're only looking at like a little more than 3 times bigger, but the volume is 49 times bigger. So one of the things, and this was part of our problem with our warm-up as well. Whenever you take radius, that's just one-dimensional, right? You measure it in kilometers. When you are finding volume, you are cubing that. So 1 kilometer is going to be many times bigger whenever you cube it. So, like here, I think this works. Let's see if this works. Notice what I get if I take my number of times bigger and I cube it. I get what we got right here. Okay, so like your radius is 3.6 times bigger. If you looked at like surface area, it would be like we'd square that, and if you look at volume, which is cubed, you would have to cube that difference right there. So you have to be really careful when you're dealing with like straight units like kilometers versus cubic units for volume. They're not going to be the same. Okay. All right. Candle A has a diameter of 4 inches and a height of 8 inches. Candle B has a diameter of 6 inches and a height of 5 inches. Which candle contains more wax? Okay, so using the information that we've got, what shape do we have, Jeremy? Cylinder. It doesn't specifically say cylinder, but it tells us about diameter and height. Okay? Look at your note card. What was our cylinder formula? Pi r squared times height. So for candle A, all right, now, first of all, did they give us the radius? It's half of your diameter. So for candle A, you're going to have pi times 2 squared times the height, which is 8. Now, I'm going to tell you, I like to do this without typing in the pi. 2 squared is 4. 4 times 8 is 32. This is 32 pi. You can multiply it by pi and get the decimal if you want. But all they're asking you to do is compare them here. So I'm just going to not even bother with that. And candle B, what is our radius for that one? And the height? 5. So that is going to be 3 squared is 9. 9 times 5 is 45 pi. Which one has more wax? B. Candle B. Okay. Now you're welcome to type in 32, like the whole thing, and get the decimal. You'll see the same thing. B's got more volume there. Okay, try 8 on your own. That right, and you're getting, this is where we're getting our 36,000. Okay. All right, so that is 36,000 cubic centimeters. Okay, but they didn't tell us how many cubic centimeters a guppy needed to live. They told us the number of liters that a guppy needed to live. So we've got how many cubic meters are in a liter. So what do we need to do here? Divide by... Okay, we could do that. That'd be like a shortcut of what I'm going to do. But yes, you could do that. So, actually, what Alex said is divide by 5,000. Why would we do that? How much does a guppy need? 5 liters, but that would be 5,000. So 5 liters would be 5,000 cubic centimeters there. So each guppy needs 5,000 cubic centimeters. So if we take 36,000 and divide by 5,000, 36 divided by 5 is going to give you 7.2 guppies. So you're not going to have 0.2 of live guppies. Hey, buddy.
You can have a deformed guppy, and you can have a...
So if you have a deformed guppy, he only counts as part of a guppy.
Yeah.
So if somebody's missing a leg, they only count as part of a human.
Yeah.
My dad, he's missing his arm. He had to have his arm amputated when he was in high school. So he is only like 0.9 of a person. Okay? All right, so you could safely you could have 7 happy guppies in there. Could you put more? Yes, but they might not be as happy, right? Yeah. All right. Okay. Okay, let's keep going. Okay, now, this is where it's going to start to get a little bit more difficult, okay? Because some of the questions we are going to get are going to be sort of backwards problems, okay? They are not going to be just plug in and find the volume. Some of them might give us the volume, okay? So this says, find the diameter to the nearest unit of a cone with an approximate volume of 22 cubic feet and a height of 21 feet. Okay? So when we see this, they gave us volume and they gave us height, right? So volume equals 22 and height equals 21. So this one is not asking us to like find the volume. It's asking us instead, what is it asking us for? Diameter. We need to find diameter. That's what we're looking for. So we need to find the formula. Which formula we're using? Volume equals 1/3 pi r squared times height. Okay? So this is the formula that we're using. We need to take the information that we have and plug it in. Now, does this formula have diameter in it? Are we going to be able to find diameter using the formula? We can't find diameter, but what could we find? Radius. And will that help us? Because we just got to double it to find the diameter, right? So, volume is 22. 1/3 pi times the radius squared times the height is 21. Okay. So when you're looking at this, it might look really confusing at first, but what you're trying to do is you're trying to get that R right there by itself. So you've got 1/3 pi and 21 are all numbers, and they're being multiplied together. So we can go over to Desmos here, and we can just type in 1/3 times pi times 21. And here I'm getting this number. So what? 21.99114. So I've got 20, ooh, that's the pen. 22 equals 21.1994 times the radius squared. Okay, so if I'm trying to solve for the r, what should I do next? All right, what do I get rid of first, the square or the 21.19? 21.19. It's like the opposite of your order of operations. So you're going to divide this off. 21.1994. I may have written that. It may not have 1. There's no 1 right there. It's just 994. Wrote that wrong. Okay. So on Desmos, if I take 22 and divide it by, I'm going to copy and paste this number. I'm getting 1.0004. So my radius squared is going to equal 1.0004 something. And then what do I have to do last to get that radius by itself? How do I get rid of a square? Square root. Alright, so if I take this number right here and copy it, SQRT, square root, I get, the radius is 1.0002. Feet. Depending on how precise you need to be, probably just 1 foot is good enough there. Mm-hmm. Yeah.
And we're not using those.
Okay, now let's think about what we know about solving equations. So let's say that you struggle with solving equations. What is an option right here? If you lost me once I plugged those numbers in, what's an option to solve an equation always? Desmos, left side is f of x equals, the right side is g of x equals. So if I lost you on that, you could. Now, sometimes the graphs on these are crazy and the numbers are big, so sometimes it's not the best way to do it. But if you're stuck and don't have anything else, instead of radius, we want to use x. Okay, and if I zoom out a little bit here, there's actually 2 answers for this one, for this equation. There is one, and it's rounding it to 1 because Desmos just goes to 3 decimal places, so it's not going to be any more accurate than that, which is fine. And then there's also -1, but does -1 make sense when you're talking about volume? No, it doesn't. So you would throw that out. So if you get a negative answer, it wouldn't make sense for this. Okay, so if you have trouble with that, we can use Desmos. All right, let's look at 10. Okay, volume of a sphere is 342 cubic inches. What is the length of its radius? So, first of all, what formula do I need?
Sphere.
Sphere. And what is that one? We just wrote it down today.
4/3 square pi to the r squared.
Very good. Okay, what did they give me right here? What does that 342 go in for?
The r.
That is volume. That's V. So it goes over here. 342 equals 4/3 pi times the radius cubed. Now, for those of you who I'm losing when I'm doing it by hand, when you see this right here, if we go over to Desmos, it's a little smaller so we can still see our equation. What could I do if I want to solve this in Desmos? F of x equals 342. Next line, g of x equals 4 over 3 pi. We don't use r because Desmos isn't going to like it, so we'll do x to the third. Okay, let me make that full screen so you can see it. And let's hit the house button so we can see what's going on. Alright, now, I don't see much going on here, but that is because what number is my top equation? 342. So if I go over here and make this y-axis go up to like 400, I should be able to see it. There it is. And 4.338 is my answer for that. Okay, so 4.338. So radius is going to be 4.338. Let me show you how to do it by hand as well. It's really not all that terrible by hand. So 4/3 and pi are just numbers, right? So I could, on Desmos, I could just do 4/3 times pi, and I want that to go away. And if I do 4/3 times pi, I get 4.1887. So that means I've got 342 equals 18879 times the radius cubed. Riley, if I want to solve that for my r cubed, what would I do first? Divide by that 4.18879. So I would, over here in Desmos, just copy and paste it. So you got 342 divided by, copy and paste that number. So that gives me 81.646. Keep that whole number equals r cubed. Josiah, what have I got to do to get rid of a cube? Not divide. It's like a square root, but it's not a square root. It's a cube root. So it's a root, but it's got a little 3 out here on the side, and a root with a little 3 out here on the side. And on Desmos, if you go right here, I think you got to go to functions, and there should be down here towards the bottom, maybe at the very bottom, there's this root with a little n on the outside. Oh, don't do it on that line, though. That's not what we want. We want to go down here and get the root. Put a 3 right here. I'm going to copy and paste that number right here, and that gives me 4.338, which is what I got with Desmos as well, right? I like doing it by hand because sometimes the graphs are hard to get zoomed in correctly too on Desmos. But Desmos is an option too for solving these once you get them plugged in. Okay, questions? Alright, so we got just a couple more, I think. Okay, a rectangular prism has a length of x centimeters, a width of 2x plus 1 centimeter, and a height of 10 centimeters. Write an expression that can be used to find the volume of the rectangular prism. Alright, so this is something they are giving you, and you can't use Desmos to do this one. This is something they're giving you to make you put some algebra and some geometry together here. Volume, they've given us the easiest volume thing we have. What is the formula for a rectangular prism? Length times width times height. We've been doing that since we were little kids, right? And they gave us that length equals x, width equals 2x plus 1, and height equals 10. Okay, so we're not going to get a number answer for this whenever we do this problem because we're plugging in variables, right? So my volume is going to be, instead of length, I'm going to put x. Instead of width, I'm going to put 2x plus 1. And instead of height, I'm going to put 10. Now, I think this problem is a little easier to do if you rearrange it. All those things are multiplied together. So I would do this. I put the 10 and the x together, which you can do because everything's multiplied right there, right? In multiplication, it doesn't matter what order we do those in. So then, Jasper, what would we do here with our 10x times 2x plus 1? How would we sort of simplify that a little bit? When we got that number on the or that expression on the outside of the parentheses, what can we do with it? There. We're going to distribute. So we will distribute 10x times 2x will give us 20. X squared, what will we get for the last part, Angel?
10.
Almost.
Oh, my bad.
10x. Okay, so this is what they'd be looking for. 20x squared plus 10x. It's not that bad. They're just throwing some algebra there in the middle of your geometry to test your brain.
I can't wait till you put the candy for discounts.
I just want to ask for extra candy.
I'm going to be working, bro.
How much candy you gonna get?
Zero.
It's not.
I'm going to get 0, bro.
I told Henry, because Hunter's not, well, he didn't last year either, but Hunter's not trick-or-treating. He thinks he's just helping with something at church, with the trunk or treat at church. So Henry is our last trick-or-treater in the house, so it is up to him to get candy for the family, for us all to eat.
So you should, like, grab
It's
multiple
family
bags.
candy.
Multiple bags. And be like, oh,
But we already have too much. He has already been like two or three places, and we already have we already have like a big like mixing bowl full of candy already. So we really don't need it.
You can donate to me.
He is he's Maverick from Top Gun. He's got like the flight suit there, so and little aviator sunglasses, so he's cute.
You can donate some candy to me if you like.
Now last year was a good Halloween costume.
What do you
I love Halloween. Let's not. All right, so okay, a cube-shaped bead has side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. So our bead is a cube, but it's got a hole that goes through the middle of it. So what shape is the hole?
Sphere.
Not a sphere. A circle's 2D.
Oval.
It goes all the way through. It is a cylinder, right? So, and this side is 12. This is 12. This is 12. Our diameter here is 2 millimeters.
And it's still like linked on paper.
So what should we do here?
I don't even know.
Okay, so we have a cube. That's very easy to find the volume of, right? Just length times width times height, or you can just do 12 cubed, right? So we can find that very easily. But it's got a hole. So are we using the full volume of the cube? No. we're taking out that part in the middle, right? So the volume of our cube would just be 12 times 12 times 12, which is 12 times 12 times 12 is going to give you 1728. We're not going to divide. We need to know the volume of the cylinder, because that's empty space, right? So this goes through the middle of our cube, right? So for our volume of our cylinder, a cylinder is pi times radius squared times height. What is the radius of our cylinder here? Very good. It's 1, not 2, because what's 2? That's the diameter. It's really easy to, like, mess that up. And what is the height? It is 12. It kind of looks like your length of your hole, but think about taking that and turning it so it's sitting on the base. Because it's going to be the same length of the, it's going to go all the way through, same length as one side of the cylinder. So if I do pi times 12 there, I will get 37.6. I'm going to just go 37.7 on this. Millimeters cubed. What do I need to do now? Subtract it. So I have 1728 minus 37.7, and 1728 minus 37.7 is going to be 1690.3 millimeters cubed. All right, so this is the sort of stuff you're going to see. Some of it will be very straightforward, plug in the values. Other parts of it are going to be a little bit more complicated, where you've got to kind of work backwards or use some algebra or things like that. Okay, so we want to go to that Desmos classroom that we were working on yesterday, and you're just going to work through those problems. I don't think we're going to get time to start 5-2. I thought we would today, but I don't think we'll have time. But that's okay. 5-2 is cross sections. I forgot to write it up there anyway. So. All right. If I were President of the United States of America,